So at this point, we've reviewed a fair amount of trig. We've reviewed SOHCAHTOA, we reviewed how to use right triangles to solve things, and that's all been well and good. But the reality is, up to this point, if I've ever asked you to, do something like, what is the cosine of 1, like the cosine of 1 radian, everybody will just go straight for their calculator. I feel like at the moment, you guys have no real deep understanding of what the cosine of 1 is, or how we could possibly even estimate what it is without a calculator. And this lesson, I hope, is sort of mind-blowing. So I hope I haven't set myself up for failure on that one. But this is really, really good stuff. I love the unit circle, and I love the way that it helps us to think about these trig functions. So for all of this lesson, what I want us to do is I want us to think about and to focus on the idea of a triangle that has a hypotenuse of 1. Right? And the idea is, imagine that you had a triangle whose hypotenuse is 1, and this angle down here is theta. If I were to ask you to find out, for instance, what the cosine of that angle was, right? How could we come up with an expression for the cosine of that angle? What I'm kind of thinking of is we don't know what what the x and y values for this triangle are, but in some sense the cosine of this angle should be the adjacent x over the hypotenuse of, and this is the magic right here, the hypotenuse is 1. Which means, if you have a triangle whose hypotenuse is 1, then the cosine will effectively be the adjacent side. Similarly, if you wanted the sine of that angle, it would be the opposite side, y, over the hypotenuse, which again was 1. So we find that the sine is effectively going to be the y side, the y component of this triangle. And so the takeaway that we're going to have here is, so long as you have a triangle that has a hypotenuse of 1, the cosine will be the adjacent side, and the sine will be the opposite side. And at the moment, that doesn't seem too mind-blowing, but I'm hoping that in the next slide we can start talking about how to estimate these trig functions, and I'll be able to really give you something amazing. So let's see if that happens. So what I have here is I have a unit circle, and I've done it on the computer so that we can see exactly what these things are. Let me explain a few things. First of all, and a question I would ask you guys, how do you know that you are looking at a unit circle? Like when I say a unit circle, what's the important thing about a unit circle? I'm pretty sure I mentioned this in a previous video. The concept behind a unit circle is that the radius of this circle is 1. You'll notice that this has a radius of 1 all the way around the entire thing. Okay? So what are these points out here? What is the 0.4, the 0.8, the 1.2, the 1.6? What are those numbers? What do they refer to? And pause the video for a minute and think about what those are. I'm hoping that you basically recognize that those are the radian values of these angles, right? Like we mentioned that our reference angle is always supposed to start with 0 degrees or 0 radians here, and halfway around the circle, we used to think of that as 180 degrees, but we're now thinking of it as sort of both 180 degrees, but also as pi radians, right? And so the idea is if you see this being 2.4, 2.8, 3, 3.14, it makes sense that that angle over there represents pi radians. So now, here's where this stuff starts to get magical. Suppose I were to ask you, without the aid of a calculator, to figure out for me what the cosine of 0.4 is. What you can do is you can imagine this unit circle, you can draw your line out to 0.4, and then imagine dropping a line straight down so that you get a right angle here. The idea is I've now created a triangle that has an angle of 0.4 radians in the middle here. And think about what you learned on the previous slide. What you should have learned is that because this hypotenuse is 1, now think about that. Why is that hypotenuse 1? That hypotenuse is 1 because this is a unit circle. Right? So that hypotenuse is 1. What is this adjacent distance? I mean, if you were to estimate it, if you were to sort of look at this and go like, oh, that looks like about 0.93. If you said 0.92 or 0.94 or 0.915, 0.9 something smallish, I'm happy. Right? Similarly, what is this vertical distance here? Well, if we sort of look at that, it looks like that's, close to maybe 0.39. what I mentioned on the previous slide is the cosine of 0.4 should be the adjacent side, 0.93, divided by the hypotenuse, which is 1. To be honest, I'm going to stop even thinking about that hypotenuse. Because we're in a unit circle, this is going to be 1, and so the cosine of an angle is going to be the x component, 0.93. Right? Similarly, what is the sine of the same angle? The sine of 0.4, well, when I go to the angle of 0.4 and look at the height of that triangle, the answer is 0.39. Now, just for fun, if you want to, punch those in your calculator. Put your calculator in radian mode and punch them in. I just did that. Turns out on the calculator, the cosine of 0.4 is 0.921. The sine is 0.389. I mean, like, we got incredibly amazing estimates by looking at this picture of the unit circle and understanding that the cosine is always going to be found by looking at the x component, and the sine is always going to be found by looking at the y component. Right? Let's take a look at another example of this, and I'll use a different color. We'll use red for this triangle. I now want you to find the cosine of the angle 1.7 followed by the sine of the angle 1.7. So pause the video for a minute, sort of draw that angle, draw the associated triangle, and see if you can figure out what these values should be. So the idea is 1.7 should be sort of up here between 1.6 and 1.7, and this is going to be a hard triangle to draw. I'm going to draw this, and then I draw straight down also, and over, and that's the triangle I'm looking at. So the cosine is, what is this x value, right? Well, you'll notice it's going backward. I'm going to the left. So this cosine value is going to be negative. It's going to be negative 0. And I'm going to estimate about 0.15. If you got 0.14 or 0.16 or 0.153, if you're in the ballpark, if you have the idea, that's what I'm looking for. I'm actually a lot less interested in actual numbers, and I'm more interested here in, do you have the idea? Do you see where they come from? What about the sine? The sine is, what is the y coordinate? What is the y value of that point up there? It is almost 1. I'm thinking that's something like 0.98. And if we wanted to, again, we could check these on the calculator. When I do the cosine of 1.7, okay, the calculator said it was negative 0.13. We were off by a little bit. When I do the sine of 1.7, it says 0.99. Okay, we were off by a little bit. These are estimates. Like, we're coming up with reasonably accurate estimates for sine and cosine values by looking at a picture. And this is amazing stuff. Let me throw one more of these at you using purple, and then I've got a couple more pages of these for us to try, because this is to me, this is a very important concept. Us understanding where these values come from is crucial. So what about the cosine of negative 0.8, or the sine of negative 0.8? So first of all, what does a negative angle actually mean? Well, a negative angle just means instead of going this way around the unit circle, just go backward. So you can sort of imagine, like, if this is 0.8 up here, our positive 0.8 value is going to be sort of down here. This angle right here is negative 0.8. So we should be able to look at a triangle, and we should be able to figure these things out. So again, come up with your estimates. For cosine, I'm estimating it's about 0.72, and for the sine, I'm estimating, to be honest, it almost looks like that's the same, except negative. So negative 0.72. Okay, so those are my estimates. To be honest, I'm not going to go through the trouble of checking those on the calculator, because we're just looking for the idea of how we set these things up. So I've got a few more of these that I want you guys to try. So I've got 5 of them here that I'm asking you to evaluate. So pause the video, come up with evaluations for these. If you'd like to, maybe do the first 3 and then watch the answers for those, and then come back and do the other ones. So, and I'll try and do these with different colors and then erase them as we're going along. For the cosine of 2.3, the angle 2.3 is over here. So then if I draw down and make this triangle, the cosine is going to be this x value here. And that x value looks to be about, negative 0.67. Again, if you had something close to that, good. Okay, I guess I can't erase that blue one. Oh well, I'll try and do a better job of erasing on the later ones. So the sine of 0.1. 0.1 is here. If we draw our triangle, right, you've got this really, really short triangle here. The sine of point 1 seems to be, again, y-coordinate, seems to be about point 1. That seems to be about how tall that is. Okay, so let's see if I can erase the purple one. Yay, we did it for that one. Next up, the sine of negative 1.3. I'll go red on this one. So, alright, so where is negative 1.3? Well, this is positive 1.3. So negative 1.3 should sort of be the same amount down this way. So if I sort of draw in this triangle, okay. For sine, I'm looking for the y component, and really that's the takeaway that we have here. The reason I'm going to have you do so many of these is I want you to know sine is always associated with a y coordinate, cosine is always associated with an x coordinate. Right? So what is the y coordinate of that point? Well, that looks like negative 0.96 or so. If you said 0.95 or 0.97, they sound good to me. Alright, so the cosine of pi plus 2, this is where things are going to start to get a little bit more interesting. How are we going to get to the cosine of pi plus 2? Well, let me see if I can erase this red stuff first, because we're going to want as much clarity as we can have here. Where will the cosine of, where will the angle pi plus 2? So pause the video for a minute. Think about how you could come up with an angle of pi plus 2. Keep in mind that we're estimating here. This doesn't have to be perfect, right? One option that you have is to look at this and say, well, what is pi plus 2? Pi plus 2 is like 5.14. So now we could stop and think, like, okay, so this angle up here at the top, I mean, actually, let's go over here. This angle over here is supposed to be 3.14. It's supposed to be pi. So if this was close to 1.5, this is 3.14, there's a sense in which this angle down here at the bottom is somewhere close to 4.5. So if we want 5.1, we kind of need to go about 0.5, so about that much angle past this. And so we can almost imagine going about that far and saying, you know, that angle right there seems to roughly be representing the idea of pi plus 2. Now, answers are going to vary kind of widely on this one, but the idea is if you can come up with that sort of estimation of where the thing is, I'm a happy camper, right? Another way of thinking about that is to imagine, it's almost like we know that this much is pi. So if I want to take pi plus this much, plus, like that's an angle of 2. So imagine taking that amount of arc and applying it right here. Do you see that? It's almost like I'm saying pi plus this much more. So I'm adding that 2 on and ending about there. So now what's the cosine of that? Well, that angle seems to be about, I'm sorry, not angle, that value seems to be about 0.45. And so that's what we'll go with for our cosine. Okay. The last one we have is the sine of 7 pi over 6. And this one, again, is a sneaky one. I'm trying to introduce some concepts that are going to be coming up later. I think of this as like 7/6 pi. So it's almost like saying somebody took pi and cut it into 6 pieces. 1, 2, 3 pieces, 4, 5, 6 pieces, and then they went to the 7th sixth. So this is 1/6, 2/6, 3/6, 4, 5, 6, 6. This is the 7th sixth, 7 pi over 6. And they're asking for the sine of that value. Well, the sine of that would be the y coordinate, which looks to be about negative 0.43. Especially in these last two, if you got answers that looked rather different, that's okay. I'm not looking for exact values. I'm looking for the idea of, can you locate an angle, draw the triangle, and look for the x or y coordinate. This last round of exercises is, in some sense, harder because I'm not going to let you have a pre-drawn circle, but maybe easier because we don't need to be exact, right? For all of these, I just want you to see if you can come up with a circle on your own. See if you can come up, don't use graph paper, don't try and make it precise, don't use a compass, just try and get an estimate, right? So for this one here, imagine you have your unit circle. Where is the angle of 1.2? Right? If we know that this is 0, the other reference I tend to use a lot is that this angle up here is 1.5, like pi over 2. Pi over 2 is like 3 over 2, that's 1.5. So an angle of 1.2 is going to be up here somewhere. Sine is then asking, what is the height of that point? And I know we can't tell. Like, I know you don't have, I know on the previous problem this was a lot easier. But can you come up with an estimate? Can you tell me something? If the height of this highest point is 1, what would you estimate that this height is? I think saying something like 0.9 sounds pretty good. Like, again, I'm not looking for anything exact. When I run it through the calculator, I got 0.93. Us being able to come up just in our heads with the idea that it's 0.93 is important to me. That's the principle I want you to use on these next three problems. So pause and try them on your own if you'd like. Check them as you're going along. The next one up is the cosine of 3. So again, where is the angle of 3? If this is 0, up top is pi over 2, that's about 1.5. Over here is 3.14, so 3 is like just barely above, like that is 3. So they're asking for the cosine, they're asking for the x-coordinate of that point. I'm thinking negative 0.95 seems appropriate. Okay, so next you're asked to approximate the values of the sine of negative 0.45 and the cosine of negative 0.45. So, if we sort of draw our unit circle over here, again, I would encourage you to think about where will you find the angle of negative 0.45. Well, if this is negative 1.5, negative 0.45 is almost like a third of the way there. If you sort of imagine splitting this arc into 3 pieces. So what we're looking at is we're looking at this triangle. Right? Now again, estimating what those things are exactly is going to be really difficult. I think the thing that I'm most interested in is, do you recognize that the cosine should be a larger value than the sine? On top of that, the sine should be negative. Like, coming up with your value of sine being something like negative 0.4 and your cosine value being something like positive 0.8, those are good. If you have anything close to that, if you understand that you drew this and you had this being your sine and this being your cosine, I'm a pretty happy camper. Okay. The last question is my favorite of all of these. Which is larger, the sine of 1 or the sine of 2? And you should be able to answer this question exactly. Right, so think hard about this one. I know we're at the end of a long video, but think hard about this one. Well, it all comes down first to where are 1 and 2 on the unit circle. Right? If this up here is, and I know I say 1.5, but it's not really 1.5. It's half of pi. It's half of 3.14. So it's really 1.57. With that said, think about where 1 and 2 are. The idea is that that the angle of 1 will be a little bit closer to 1.57 than 2 will. Right? So in other words, this distance is a little bit smaller than this one is. So what does that mean for the sine values of these two things? It should mean that this is going to be a little bit larger than this one is, because the 1 angle is a little bit higher up, a little bit closer to that maximum than the 2 angle is. So here we are, we're at the end of this very long video that's covering the idea of how we can estimate sine and cosine just using a circle and just using our knowledge of this stuff. What we do with this is going to get a lot more precise in the coming videos, but for now I want us to have this concept, and this concept has to be deeply embedded in your minds if we're really going to make good sense of the stuff that's coming up. So I'll see you in the next video.